So today we're going to discuss the firewall policies. I'm pretty sure most of you are familiar with it, but we still just want to go through those, make sure all the pieces are there because are important for the test. Since the firewall policy is one of the key elements on the firewall configuration, everything we want to do on it pretty much require a policy. So that's why we just want to go through all those elements again. What the policy is going to contain, the UID, which is just a random characters that you usually only see when you are dealing with the CLI, but it's important if we start doing API calls, we need to reference those IDs, the source interface, destination interface, the action, the destination, the schedule, all those elements that we are familiar and we're going to see on the lab for a policy. And probably the most important piece is what we're going to do with that policy, right? We're going to accept the traffic that we are specifying, or we are going to deny that. And depending on if it is an accept or a deny, then we obviously can do different things. For example, if we are denying, we can create some additional logging for that information, since we want to know why we're receiving the traffic in some cases, because probably we're not expecting it, which is probably something we shouldn't want to see in our environment. So depending on the actions that we take, the behavior and the configuration of our policy is going to be different. So we are just going to glance of each of the key elements of a policy, the incoming and outgoing interfaces, and with what things will we need to keep in mind for those, the source, the schedule, and obviously the services, which are really important. The incoming interface or interfaces, if we apply multiple to our policy, is just going to be where that traffic is being received, and the outgoing is where that traffic is going. We need to remember that the outgoing traffic must match what the routing table is saying. So if we receive traffic on port 1, the routing table is saying the traffic needs to go out on port 2, but our policy is configured with outgoing interface port 3, then it's not going to match, and it's not just the policy is not going to work. It's not going to find the correct match of traffic going in on port 1, going out on port 2. Other elements is the source address that we're going to have. We can also have groups for that, so it necessarily is going to be one element. And again, we're going to review this in more detail when we go to the lab. But we just need to remember that the more specific that we are with those policies, with those source addresses, is just going to limit the scope of our policy, and probably we can be more granular with the type of policy we are creating. The source address, or the source field, I should say, can also include a source user. If we don't have an integration with an Active Directory like LDAP or SSO, for example, the source user is not really helpful because it creates more management and a lot of overhead for our firewall configuration. But it's really powerful when we have zero trust and the security fabric is identifying the users that are directly connecting to our environment. Therefore, we know that Bob is from sales, and maybe Bob can go to Facebook because he needs to do some interactions there. I should say marketing, not sales. I guess that will make more sense. Bob from marketing needs to go to Facebook to do his job, really. But maybe Alice from IT doesn't really need to go to Facebook. By her role, there's no purpose for that. So we can identify those users and apply the correct policies. Similar logic for the destination address. We can either have a single destination address, have a group, or use one of the internet services that Fortinet already provides. Those are really helpful. I really love the services that we can define from their internet database, and we can review those in the lab as well. But keep in mind, they're always present we can always use them, and Fortinet prefers that we do. So that's one of the elements. If we have to compare between two policies, which policy is going to be better is the one that is using more intelligence, not only from the FortiOS, but also from the security fabric. So if we see a user or groups over there that identify a department or something like that, that's probably the better choice. Schedules, we can apply policies for schedules. I don't see this used very often in the wild, but the idea is that maybe we're going to allow Facebook route during business hours or consume media like YouTube, but then during after hours, since we don't expect anybody from the office to start doing that, then we're going to block that. And this is for two reasons, really, the schedule. One, to have that sense of control and automation for the user needs, to understand their needs, but at the same time is for us to understand and see what's going on at night. So let's say we see in traffic, which now that is blocked thanks to the schedule, for YouTube or for Facebook at 9-10 p.m., when we are not expecting that, that will obviously raise a red flag, and we can investigate what's happening. Maybe someone is already on our environment and is just doing that at night, consuming our resources, consuming our internet, which obviously are things that we don't want. Finally, the services is when we can list all the destination protocols that we're going to use for applications. Again, if we have an option that applied for our cases to use the services intelligence that comes from an internet database, please do so. And as always, and again, I'm pretty sure everybody's familiar with it, if we don't have a specific allow in our policy, there's always an explicit deny. After exhausting all the policies in our list, if none of the policies allowing the traffic that we are receiving, then that traffic is going to be denied and dropped. The order for the policies is really important, and the firewall is going to try to, well, not try, it will release those traffic, those flows as soon as they receive them. First comes, first serve. So also we want to make sure that we don't want the firewall to be a bottleneck in our environment. So the order for the policies is important. Try to always put the denies at the first, then the more specific rules second, and then wider, more broad access later on the list. The reason for that is just to prevent user error in the future. If we're already blocking something and then by mistake or already on purpose we are saying, okay, allow everything else, if we don't have the correct order, that allow everything else could potentially allow what we are trying to block later on if we don't have the order correct. At the same time, if we know we're going to drop some type of traffic, we don't want to waste our resources and CPU time by going throughout the list just at the bottom. Oh, I'm going to drop it. Might as well drop it at the beginning and then just forget about it and free up those resources for other traffic. Our policy applications and all the security applications and profiles that we can define on the firewall, many and as well, depending on what type of traffic we're expecting, sometimes we're going to allow some or not others. I'm not particular a fan of allow all and then you just apply all the policies over there, web filter, antivirus, application control, because you are wasting resources for your firewall. And sometimes you're going to inspect traffic that is not going to apply for any of those security policies. So if you can be a little bit more specific, for example, web traffic, right, going to port 80 and 443, then we can apply the web filter there. or an antivirus. But other traffic that is going to, or maybe not as common ports, then we can apply the application control there. And again, this is depending on your situation and what type of traffic you are seeing in your environment. And I always try to come up with an examples to like an office type of space, because I think is most familiar for everybody. But if we are dealing with data center traffic, with API requests, VPN connectivity, or any other type of integration for our applications, obviously that is going to change. But just keep in mind that as much as we can, we always want to be specific and granular with our policies, so we can optimize that. The implicit policy, like I already mentioned before, is there's no matching at the end, well, it's going to be deny. There's little customization we can do with that implicit deny, but really it's just, are we going to log this or not? And then we can apply the policies needed for that. I personally would recommend you not to block, not to log that type of traffic. If you are interested in something that you want to block, create its appropriate policy, block that, and then log if needed. Best practices, we've mentioned before, block first, more specific rule seconds, and then bigger, wider access later on. And try to always apply the policies and the security profiles where it fits the best. The UID support, we mention it just because if you see a question about API connectivity or how to identify a policy, that's what you will use if you want to do it programmatically. Otherwise, from the GUI, we never are going to see that value, and we really don't care too much. But just keep that in mind for the test. So enough talking. Let's go to the demo environment. I have a firewall over here, and we're just going to go through a few policies example and just reiterate everything that we just discussed. So I already have a policy here for just one computer I have my firewall. If this ever loads, there we go. And I know I said I'm not super happy about my all allow everything, but this is my lab environment, and I just wanted to keep things simple because I want to point out a few little elements here. So let's create a new policy. And by the way, if you didn't notice, we are using 40 OS 7.4 point something. So it's the latest available at the moment. Why is wrong with this? Okay, so we need a name. Since we are not using zero trust, we're not going to select that. It's going to be a standard policy. The incoming interface is going to be port 2, and it's going to go on port 1. I don't have additional ports, interfaces, but if needed, I can always add more. And this is useful only when we have like multiple exit points. So instead of creating multiple policies, just create one policy that will account for all your ports. Maybe if you have two internet connections, one from, I don't know, Verizon and the other one from AT&T, instead of have two policies, just combine those for a better use of your policies. For the source, we can always either use one of the addresses, and this could be very specific to one IP or one subnet, or in this particular case, when I'm showing all, it will be all. But keep in mind always that we can create a user, consume users either from the local database, which again is not very recommended, but possible, or the better option, if we implement zero trust or device tracking for user control, then we can have that intelligence that will come from the security fabric here to restrict those users. And we go back to the example of Bob from marketing can go to Facebook, but Alice from IT cannot. And as always, if you can use the internet services either for your source, depending on your traffic, or your destination, that's where I see it more commonly used, please do so. For right now, I'm just going to go simple. I'm going to allow all. For my destination, just because I want to point that out, something Meraki, because I was doing that earlier today. I really like this because Fortinet is going to have that those internet data. The internet database is going to be updated regularly. So I know that, for example, in what I was doing earlier today, all those switches that they need to connect to the Meraki cloud, I mean, just for management, instead of providing them full internet access, I'm just going to limit it to the Meraki cloud. That way, I'm sure that hopefully it never happens, right? But if there are actors in my environment, I'm just limiting to the access that they're going to get. And if Meraki deploys more data centers, more IPs, or change that, I don't need to worry about to come back to my policies to update all that information because the internet database will do that for me. I need, in this particular case, I need to enable NAT. So we're going to have that. We are not using a specific IP pool. We're going to review that later throughout the course if we can. Obviously, security profiles. I'm not going to apply one right now, but we will in a moment. And obviously, if we want to allow tracking for that particular policy that we are creating. And this one is really good only for troubleshooting, though. We can enable this to capture packets that are using that policy. Either if we allow or deny, we can capture those packets and then we can analyze those in Wireshark, for example. So I'm going to click OK because I want to show you something. Actually, I messed up. It has to be port 1 going to port 2. Sorry. Let me fix that. Oh, yeah. I was playing too much with that. I still did it wrong. Let me switch that. Oh, actually, no. I don't know if you guys are familiar with this, but we can always right click and it's not letting me do it. Right click. And we can create a reverse policy, but it's not allowing me because the destination is a security, it's an internet database. So I guess I'll just fix it. 1 second. Just because I want to show you something when I have them. It doesn't need to be like this, but it's just visually will look better. So we know that the ID for the policy is not the sequence. So if we go to the CLI and we do show firewall policy, we see my allow all that I created earlier is has ID number 1. The one that we just created is ID number 2, and the order is obviously 1, 2. But we mentioned earlier that the order of our policies is really important, and on the GUI we can easily drag and drop, change the order, and obviously that will change the behavior of our policies. Maybe we are blocking something earlier. But look, the IDs do not change. And if we go back to the CLI, the IDs do not change either, just the positions of where they are. And that's why when we're trying to do this programmatically, we need to remember that and use the UUID to reference those policies. So just keep in mind that there's no sequence here. It's just strictly what's the order. And the ID is just there to have a type of, I don't know, identifier for the policy, but it doesn't mean that's the sequence order. It's just going to go the sequential order for the policy. Okay, so let's go back to the slides. let's talk about a little bit of other things we can do with the firewall policies, and then we can go back to our lab. So the application control and signatures, we're going to demo that pretty quickly here in a moment. Well, but for whoever is not familiar, one of the security profiles that we can add for the Fortinet in our firewall is the application control. The firewall is going to understand the traffic is seen, and according to that, it's going to designate the application is used if, and this again, this comes from FortiGuard and all that information they have over there. But really what we're trying to do is, well, not trying, what the firewall is going to do is going to see the traffic that is going through it, is going to identify it the best it can with the information is coming from FortiGuard, and to say, well, this is web traffic, this is video traffic, this is torrent or point-to-point traffic. And once it's flagged, then we can do things with that. Now that we have identified the traffic, then we can know what to do with it. So going back to my Bob example earlier, we're going to do two things. Either we're going to allow that user and see how that will behave. And remember, it will just be kind of automatic if we have zero trust or AD connectivity. And also if we are doing the application control, how it's going to look for the user and what we can see in our logs. And we can create custom signatures if needed. We're not going to do that in this lab, but just keep in mind it's something we can do. And for the test in particular, you want to know on all the security profiles, especially application control, intrusion prevention, and web filter, where you can do some type of override. So keep that in mind. Play with those when you have time, and remember when you can do those, where you can do those overrides, and what those overrides can do. We're definitely going to elaborate on that for web filter later, but for right now, it's just going to be a simple rule over here. All right, so let's go back to demo computer. We're going to play a little bit with the application policy profile, the application control profile that we checked earlier. So this is my demo computer over here. So let's open Facebook. That worked. Let's open Twitter. That worked. There you go. I'm not sure if Reddit is flagged as a social, but we'll see. But as you can see, at least those websites are working. So if we go back to our firewall, back to our policies, I'm going to apply, since the other one, because it was just a random one that I created for Meraki, won't apply for this case. I'm going to edit my allow all. And I'm just going to apply the block social media application control. That will require to define a type of inspection. Since I don't have a proper certificate in my environment, we're just going to go with certificate inspection, but obviously it's more preferred if we can do deep packet inspection for additional features from our security profiles. So we're going to click OK. That's going to apply. So now we just need a few seconds for that to kick in, and also I need to refresh my own sessions. So let me open the browser one more time. There we go. So let's try that again. Facebook. It's loading. It's not going to open. It's been flagged as a social media. It's not going to work. Twitter, or I should say maybe a different one, different tab. We can see both pinning, nothing. Let's try with Reddit, the one I wasn't sure. There you go. Reddit is not considered social media, at least from the Fortinet perspective. So that won't work, no problem. Facebook and Twitter are still spinning, they're not going to work. And that's because of the policy that we just apply. YouTube is not social media, it's more video, so it's not one of the applications that we are flagging, so that one's going to work. So if we go back to our firewall, we can see immediately the effect that our policies and our security profiles will have to our traffic. And again, we need to remember the impact that we have and why we want to be very granular and try to be specific when we apply those profiles and when we create our policies all together. So let's go back to our firewall and check the logs. If we go to log and report, forward traffic, we're going to see a bunch of traffic that our computer is being generated. But particularly, I just want to point out that the firewall has correctly identified the application that we were trying to launch, which is Twitter in this case, and it's being blocked by the policy that we not the policy that we have, but also by the security profile that we attach to that policy. And if we dig it a little bit further into that specific log, we see, well, it's coming from it's going out on port 1 to this particular IP. That the application control information that we have has flagged that as a social media defined by Twitter, which is the application ID with these particular details. And you can see that, actually, I will show you that in a moment, from FortiGuard and the different database information that they have and all the other details, right? And if we scroll down a little bit, there we go. We have Facebook over here, which also was flagged as, well, identified as the application was correctly identified. It was Facebook what we were trying to access, and because of our application, it was blocked. And if we go to FortiGuard Internet Service Database, yes. This site is going to give you all the information, or at least idea of what each services that is coming from FortiGuard database for the internet services are. So maybe if we go to the latest version of it, here, the latest version, we can see Acton NTP, which I don't know what it is, has 144 entries inside that package. And this is just going to keep getting updated throughout time. If we click on it, we will have an idea what it is. It's a network protocol that is coming from the act-on.com website. Right now, I want to see if I can show you this. Let's see. Yes. See, just by jumping to a different version of the internet database, now we know that the Acton NTP, instead of 144 IPs, has 267. And that's an older version. That's from September 28th. At the time of recording, that's roughly 15 days ago. So that means that service, they decreased the amount of data center presence, servers, IP, whatever they did, that changed. And FortiGuard just automatically update that. In that information, our policies are going to also automatically going to have that. So that's the benefit of using the internet services database. And that's why I encourage you to always use it in your policies. We just want to mention a little bit that don't forget, and I know I mentioned it, but the internet services, although we use them, in this case, on my previous example, as a Meraki destination, it was a destination field. We can use this same information for the services. Maybe we know, and it will be even better when you can combine those elements. Maybe we know we're going to Microsoft, Azure, for example, but then only to consume Active Directory. So we can tie that services and say, hey, go to Azure's hundreds of IPs that we need to whitelist for that. But instead of allowing everything, just these particular services that we are using. Again, just to limit our scope and make our firewall policies more efficient. The port mapping, yeah, this is important for the test too. The port mapping in the internet service database is utilizing this from all the default information, all the default settings, I will say. So we know that commonly web traffic is port 80 and 443, but we know that if we have applications internally, sometimes web developers like to change that to port 8080 or something else, right? So how the firewall is going to know that 8080 is just not a random TCP port, but actually we are using within our organization as a web traffic. We need to define that so the firewall can identify that traffic correctly and again apply the correct policies to that. And I'll show that in a minute. Just want to go through a few more slides. We will do the port mapping in a moment. The protocol enforcement, this is another security option that we have. And like we said before, we can tell the firewall, hey, web traffic is not only 80 and 443, it's also 8080 in this particular example. But we can also tell the firewall, hey, now that we know that web traffic is just on these 3 ports, do not allow it on anything else. Maybe someone tries to go to a website on port 8080. I'm sorry, not 8080. That we already whitelisted that. I will say port 1234, or a particular service that I use at home is Plex Media Server. The TCP port for that is 32100, I think. It is still web traffic, but because we are enforcing it with the protocol enforcement, it's not listed there. It's not going to allow that. So again, more security options by understanding what traffic we are seeing on the environment and how can we limit what is allowed through it. The protocol enforcement this is an example of how we can set it up through the GUI. The violation action, double check that as well if we need to create some alerts depending on when we see this type of traffic. And the enforcement can be defined in the application control versus the protocol mapping is for the inspection. So 2 different places that work together, and we will see that in a moment. And this just an extra step on how we configure the protocol enforcement through the GUI within the application control. All right, so let's go back to our demo computer and let's see where we can define all those elements. We go under security profiles, SSL, SSH inspection. Here's where we can define the port mapping. You will need to create a new profile for this, or you can use the custom one, whichever, but just keep in mind that they need to be defined here and therefore use in your policy for that port mapping to actually work. So over here, we know that HTTPS is 443, but maybe it's also going to be 8080 in our environment. And if I want to expand my Plex media server, then I think it's 32, but you get the point. So you just define the ports here that you are going to also consider in this particular case web traffic and save that. But for the protocol enforcement, that happens on the application control. I'm just going to use the blog social media that we already have for laziness, but it will be in this particular box. And again, for the test, remember that each of the security profiles, the antivirus, the web filter, the application control, the intrusion prevention, are going to have some type of overrides to change the default behavior. So keep in mind where that is and what can you do with all that. And we're going to check a few of them throughout the course, but please keep that in mind and play with those before your test. But the application and the network protocol enforcement, we need to enable that. We get the box. And we can define what ports are going to be here. So maybe I will say 8080, oopsie. And I'm going to define that as my HTTP protocol. And I'm going to expect to see 8080 as a HTTP flow. I'm never going to try to see that 8080 as an SSH connectivity flow. And obviously the type of how that connection is established is what's going to help the firewall to determine that. And then the violation action, we're going to either block that or we're just going to monitor what's going on over there. So let's go back to the slide. We just have a few more things to discuss. For the test and for your troubleshooting purposes, Fortinet is really helpful with the diagnose test application, something that is going to give you a lot of option and flexibility when we want to troubleshoot or test one of the little services that we can configure throughout any of the location of the firewall. So keep this in mind. Consider all of them, especially for the security profiles. How can you test your intrusion prevention? How can you test your application control? How can you test your web filter? Usually this CLI tool is going to be really powerful, and try to get familiar with them. Like this one, 99, is going to restart the DNS proxy worker. Usually the 90 plus values are going to be for restarts. So keep that in mind. Look at them, try to play with them, so you're ready for your test and your day-to-day, how you can troubleshoot and make sure that your applications and your profiles are configured correctly. So don't forget what a firewall policy, all the different elements that we can have on a firewall policy, the interface configuration that needs to match what we have on the routing table, source and destination addresses, or internet services database to enhance that information. The same for the services. If we want to apply a schedule or not, if we want to log that traffic, if we want to capture that traffic that we see there for troubleshooting. Remember all the different things that we can do on a policy, since that's the bread and butter for our firewalls. The application signatures, what we can do with them, social media, web client, remote traffic, point-to-point, the protocol enforcements, all the little things that we can do and modify for application control, and the protocol options that we can also include more ports as part of the inspection for identification later on. Thank you.